Now we're looking at condition for maximum range given a fixed initial velocity. Let me explain this. So look at this simulation. Let's not get distracted. Look at the velocity. It's 70, right? And look at the angle. It's 15, and Vx, Vy is where the particle is, and so on and so forth. So the journey is not yet started. Now look at the object and look at the black line. Now what will I do is I'll increase the velocity a bit. So 75 to 80. So what happened? The range has increased. So I will fix the velocity to be 85 and I'll play around with the angle. Okay, actually let me fix it to 75 itself. So I'm fixing the velocity to 75 pixels per second. I'm fixing the angle, not fixing the angle. I'm varying the angle. Let me vary the angle. So this is at 15 degree. This is at 20 degree. So there's a huge jump in the range. Then this is 25. Then look at the angle, that is 30, and look at the range. Keep observing the range. Observe the range. This is 35. This is 40. This is 45. 40 and 45, there's a small difference, but 45 is a bit further away. Now look at 50. Look at 55. Look at 60. Look at 65. Look at 70. 75. Look at the angle, right? This is 80. So what happened? If this is 80, this is 75, it's increasing from 80 to 75. 70, again it's increasing. 65, it's increasing. 60, it's increasing. 55, increasing. 50, increased a bit. 45, it increased a bit. 40, it reduced. 35, it reduced. 30, it reduced. So this is happening. And we got to see that maximum was where? 45. Given this flat surface, the object is able to travel the farthest with 45. Anything else was less than that particular value. 45 and 50 were close by, but yeah, we have 45 to be the maximum. So we are trying to prove that maximum horizontal range. Okay, so we know the horizontal range. Now we're looking at maximum range. So we know that range is given by V naught square by G sine 2 theta. Honestly, if you guys know derivative, this is much simpler. Or if you know trigonometric function, that also is good enough. And we also know that sine of any angle, sine of x, or let me call it as sine of alpha, the range is between -1 to 1. That is maximum value of sine alpha is 1. Do you guys agree? Therefore, the range max will be V naught square by G into sine 2 theta, that is 1. So this is the maximum range, but we're looking at the condition. See, remember this V naught square is fixed, G is fixed. So this is the only thing that varied. So the value sine 2 theta is maximum for 1, right? So sine 2 theta being equated to 1. This happens when 2 theta is sine inverse of 1, that is 90 degree. So therefore theta is equal to how much? Theta is equal to 45 degree. Okay, I'll repeat this entire thing again. So we are looking at maximum range. So we know the range value. So this is fixed because we are fixing the initial velocity. G is fixed near the surface of the earth. This is the only thing that can, so these two are not in play. This is the only thing that will vary. So sine 2 theta has a maximum value for 1, as a maximum value of 1. When does that happen? When it is 90 degree. Okay, so how do we, then when we simplify this, this is equal to 45 degree. Do you guys agree? So at 45 degree, the object travels the farthest. That we have seen for different cases. right? We got to see that.